Now we're going to take a look at 6.2 and let's finish this up. So yesterday we started going over exponential functions. We talked about how we name these. It's going to be important that you think of them according to their name. So this would be exponential base A. In this example right here, this is exponential base 3. This is exponential base 1/3. This is exponential base 4. And this is exponential base 1/2. If it's a number that bigger than 1 for the base, then it's growth. If it's a number less than 1, then it's decay. And when we went over these yesterday, everybody said, okay, yeah, we got this one figured out. We remember this from 1010. This isn't too bad. You should have all of this very well understood and pretty much memorized. That's exponential base A. It goes through these 3 points, -1, 0, and 1. That one's always a 1. The negative makes this the reciprocal of the base, and the 1 is just the base. If you plug a 1 in here, you just get whatever the base is. Okay? Again, growth if it's bigger than 1, decay if it's less than 1. The domain is always negative infinity to infinity, all reals. You can plug anything you want into an exponential. Okay, there's no division, no even roots, no logarithms, nothing weird like that. We'll get to logarithms soon enough. Okay, and the range is from 0 to infinity. It's always a positive number. That's what you get out. Okay? And then we talked about what the horizontal asymptote is. Either on this side it approaches 0 or on this side it approaches 0. Okay, any questions there? Okay. We also reviewed how to transform a function. So we took the top half of a sideways parabola, the square root function, and we stretched it, shrunk it, slid it right, left, up, down, labeled the points and all that sort of stuff. And everybody said that was okay. That was pretty easy, right? Okay. We're now going to do the same thing with exponentials. So we've got to understand the basic shape of an exponential based on this stuff right here. And now we're going to stretch them, shrink them, slide them right, left, up, down, and all that sort of stuff. And label. How many key points do you have to label on an exponential? 3, because that's where the bend happens. Those 3 points are where the biggest bend occurs. Okay? All right, so 2 to the x minus 1. Okay, what's the name of this function right here again? Exponential base 2. Exponential base 2. So is that growth or decay? That's growth. Okay, just slight growth. So I'm going to graph the original one. It would go through -1, 1/2, 0, 1, and 1, 2. So this is what the original one would look like. And you'd need to know those points right here. And you'd need to know, that's really fancy. That doesn't even look right, does it? Y equals 0 is the horizontal asymptote, right? What does the -1 do to the graph? Moves it down 1 unit. Okay, what coordinate's going to change then? The y coordinate. All we're doing is we're taking that exact same shape and we're sliding everything down 1 unit. So anything with a y in it is going to change by 1. We're going to subtract 1 from it. So this point right here is going to slide down 1 unit. That's going to put it right here. This point right here is going to slide down 1 unit. That's going to put it right there. This one slides down 1 unit. That puts it right there. This, remember, is y equals 0. That's got a y in it, so that will also slide down. What's our new horizontal asymptote? Y equals -1. Oops. So it might be a good idea to kind of graph that horizontal asymptote. Run along here, hits here, hits here, hits here, and then goes like that. Okay? So I've labeled the horizontal asymptote. We want to label the points. If this point was 1, 2, where is it now? Okay, the x coordinate's the same. We just bumped down the y coordinate just a little bit, so that's going to be 1, 1. If this was 0, 1, we didn't change the x coordinate at all, so it's still 0. It used to be at 1, we bumped it down 1, so now it's going to be 0, 0. It even looks right. And this point right here, the x-coordinate is still -1. What's the new y-coordinate? -1/2. Because if we were at a half and we subtract 1, that's going to put us at -1/2. If you can graph that, no one's going to argue that you don't know what you're doing. Okay? We've got the horizontal asymptote. We've got those 3 points where the bend happens on this graph labeled, and we're in good shape. Again, do not use an XY table. The only reason we used an XY table up here is to just get used to these shapes. Okay? You want to have those 3 points memorized on the parent graph, and then you want to take those and you want to move them along with the asymptote. Okay, are there any questions? Okay, I'm going to slide this one over just a little bit, and let's take a look at this guy right here. Okay, I'm going to do this one in red, and we'll do this one in blue. What does the negative do to that exponential function? Who said that? It is a vertical flip. Okay, it's just like if we had -x², that would be a vertical flip. It would take the parabola, instead of opening up, it would open down. So we're going to take the regular shape that looks like this. Oops. Something like that. And we're going to do a vertical flip with it. So it's going to open down. So that means instead of going through -1, yeah.
I have a question. How do we know why? Like, how do we know that?
Oh, how do we know that's what the exponential looks like?
Yeah.
Because it's, so let's run back and go through this. Okay, so here's the parent graph. I'll do this in black. 2 to the x. Remember, it's always going to go through these 3 points. -1, 0, and 1. That's always going to be a 1. What does the negative in the exponent mean? Reciprocal, right? So that's going to be 1/2. We put a 1 in here. 2 to the first is 2. Those are the 3 key points on the exponential function, exponential base 2. So it's going to go through -1, 1/2, 0, 1, and 1, 2. So those are the points. That's how we know the parent graph. So you could think of each one of those as a parent graph. Okay, and the horizontal asymptote is y = 0, right? We're going to take that shape, and what do we do with it to make this red one right here? Okay, so that's going to be a vertical flip. So instead of going to -1 and up 1/2, we're going to go to -1 and down 1/2. Instead of staying at 0 and going up 1, we're going to stay at 0 and go down 1. All we're doing is, this is a vertical flip, so we're only changing the y-coordinate. Only the y-coordinate's changing here. So if this was 1, 2, this is going to be 1, -2. Now, if we change everything that has a y in it by vertically flipping it, what do you get if you flip y = 0? Isn't it still y = 0? Didn't go anywhere, okay? You can't vertically flip it if it's already on the x-axis, okay? So y = 0 is our horizontal asymptote for that red one. Okay. Any questions there? Okay, let's do the blue one. Okay, what does that negative do? Okay, that negative is a vertical flip. Okay, it's outside the function. Remember, if we change the function after we make the shape, so the exponential function makes this shape, multiplying it by a negative after does a vertical flip. What about that negative right there? Okay, very good. That is a horizontal flip. Now, yesterday we did problems like this, so let me reduce the size here. There's one right up above it where we did a vertical flip and a horizontal flip. So this took that sideways top half of a parabola, flipped it vertically, made it come down here, and then flipped it horizontally. So we did a horizontal and a vertical flip. We're going to do the same thing on this one. Okay, so why would I put both of these on the same set of axes? Okay, don't we already have a picture of what a vertical flip looks like? So now all we have to do is we do a horizontal flip. Here we flipped it across the x-axis. Now we're going to flip it across the y-axis. So I'm going to take horizontal flip. I'm going to take the right and switch it over for the left, and I'm going to take what's on the left and switch it over to the right. So this point right here, if it's at 1, -2, where is it when I do a horizontal flip? -1, -2. If I do a horizontal flip on this point, does it go anywhere? Nope. Where does this point go? It's on the left over here at -1. Now it's going to be on the right. That point's going to be 1, -1/2. So that graph looks like this. So here's the blue graph, and here's the red graph. This one is just a vertical flip. So there's the original shape. We did a vertical flip, we get the red one. If you do a vertical flip and a horizontal flip, you get this one right here. So take a look at the blue one and the original black one. Doesn't it look like a vertical and a horizontal flip? In fact, if we did the horizontal flip first, it would look like this. And then do a vertical flip, it would just flop down here, and there you go. Okay, any questions? Okay, let's look at this one then. What does the negative do? Okay, that's going to be a vertical flip. What does the -1 do right there? Okay, that's going to be to the right 1. And what does the +2 do? Up 2. So we're going to take that standard shape that looks like this. Let's do it here. Goes through 1/2, then 1, then 2. Looks like this. These points. We're going to do a vertical flip, so that's going to make it go like this. See how we're kind of graphing it in stages? Okay, this is the right shape. Just like we had before, that's the right shape here. We now want to take that and we want to move it. Where do we want to move every one of those points? Up 2 and to the right 1. Up 2 to the right 1. So I'm going to take this point, well, let's do the easy one. Let's do this guy right here. Up 2 and right 1. That's going to put us right here. Up 2 to the right 1. What's this point right here? -1, -1/2. So if I go up 2, that's going to be 1. That's going to get me to 1/2. This is going to put me at 1 1/2. And then I'm going to go to the right 1. That's going to put me right here. So those 3 points are where the bend happens. Now, everybody watch, please. Watching? Okay, people mess this up. They get this and they say, okay, it's got to look something like this. Let's hit these and then go like that. Okay, you need a couple things in order to get the graph right. You've got to get the right shape. Okay, this graph has an asymptote. It was y = 0 here. We took that entire graph and we did what with it? Pushed it up 2 and to the right 1. Well, if you just take a horizontal line and slide it up and over, it's still going to be a horizontal line. It's not going to be at y = 0 anymore. Where's it going to be? It's going to be at y = 2. So I'm going to write y = 2 is our horizontal asymptote, and I'm actually going to draw it. See how I start over here at 2? And what that helps me do is that helps me get the right shape. Because then I'm not just drawing any old curve and having it kind of wildly go around here. It's going to run along 2. It's going to hit here, here, and there. Okay? Now, we'll label these points and we're set to go. What's this point right here? Okay, it is 2 0. This point right here is 1 1. And this point right here is 0 and 1/2. 1 1/2. So let's put 3 halves. Let's put 3/2 there. Okay, any questions? Okay, 2 things. You can put your pencils down and just watch. You don't need to write any of this down. This is stuff you've got to think through. There's a lot of thinking in 1050. You got to put these pieces together. I just want to show you this. Okay, this is easy to count off because these are nice whole numbers. So when we took this number right here, which was 0, -1, I could just go, well, gosh, all we have to do is go up 2, 1, 2, and over 1. And that puts me right here. I put it there, and then I can just look at it and count. Oh, that's over 1 and up 1. But let's just double check. If I go up 2 from -1, -1 plus 2 is +1. I'm in the right place as far as the y coordinates go. And if I'm at 0 and I add 1, that puts me at 1. That gives me the right coordinates there. That's going to be important in just a minute because the next ones are not going to be so nice. Okay? So make sure you can get from here to here by thinking about, oh, I'm going to go up 2, -1 plus 2 is +1, and I'm going to go to the right one, 0 plus 1 is 1. You need to be able to arrive at those coordinates that way. The other thing is, these points are on the graph of the equation. If they're on the graph of the equation, they better work in the equation, right? Let's check and see. If we did this correctly, this better work out. So I'm going to put in a 2. Let's put a 2 in right here. If we put a 2 in right there, here's what we get. We get -2, 2 minus 1, plus 2. So this is going to be 2 minus 1 is 1. 2 to the first is 2. With a negative in front, this is -2 plus 2. -2 plus 2 is 0. It does work. It should be on the graph. We did that correctly. Okay, any questions there? Okay. All right. Now we're going to do the more interesting ones. We're going to do the same type of transformations, but we're going to do them with a graph where the numbers, where the points that we graph aren't quite as nice. These were all nice numbers. I mean, look how easily they worked out. They're all like a half or 0, 0 or 1, 1, 1, 2, different things like that. Okay? Exponential base e, with the natural number there, those numbers aren't quite as nice. They're pretty ugly decimals. They're, in fact, irrational. Irrational. They're not very nice numbers. So, Kirsten is going to help us come up with the numbers on this one. Okay, what do I put here? Okay, and which of these 3 can I fill in right now? It's going to be a 1. Okay, what's this one? That's going to be E, and this is going to be 1 over E. Now, just for perspective, remember E is about 2.71. So it's a little bit less than 3. It's a really ugly decimal, again, an irrational number. So this is going to be 1, 2.7. So I'm going to go to 1 and I'm going to go up 2.7. So we're going to just eyeball it. We're going to put it about right there. That's 1 comma E. Zero, 1 is a piece of cake. We can label that exactly. So this one's 0, 1. Okay, now, -1 is easy. What about 1 over E? Okay, this is either, it's kind of like 1 over 2 or 1 over 3. It's a little closer to 1 over 3, so it's about 1/3. Okay, it's a little bigger than 1/3. Okay, but for all intents and purposes, let's say it's about 1/3. So we're going to be about right here. Now, it's not really important where you put it, as long as you put it in between 0 and 1. What's important is that you label it correctly. So that is -1, 1 over E. There's one other thing that we'd want to label if we're going to graph this correctly. Y equals 0 is the horizontal asymptote. So we've got our horizontal asymptote here. The graph is exponential growth. So it starts down on the x-axis, or really, really close to the x-axis, and then just gets bigger and bigger and bigger very quickly. Okay, grows really fast. Okay, that's the parent graph. Now we're going to take that graph and we're going to do some transformations, and we want to be able to label the asymptote and 3 key points on the graph. Okay, again, the points where the bend happens. Okay. Any questions? Okay. Let's take those points, and what are we going to do with them? What does this 1 do? Okay, that's going to take the graph and move it up 1. So that's going to be up 1. What does the negative with the x do? Horizontal flip. So we're going to take this graph that we just did, and we're going to do a horizontal flip, and we're going to move it up 1. So if I do a horizontal flip, everything that's on the right goes to the left, and everything on the left goes to the right. So that's going to be here, here, and here. So it's going to look something like this. What's the new horizontal asymptote if that's all I did? Still y equals 0, right? Okay, so that takes care of the horizontal flip. What do we want to do now? We want to move everything up 1 unit. So if I take everything and I move it up 1 unit, what's my new horizontal asymptote? Move it up 1. It's going to be y equals 1, right? So my new horizontal asymptote is y equals 1. So I'm going to write y equals 1. That's my horizontal asymptote. Okay, now, here comes the tough part. One of these is easy, 2 of them not so much. I need to take that point right there, and I also need to move it up 1 point. So if it was at 0, 1, where is it now? 0, 2, piece of cake. This point was negative 1, comma e. Negative 1, comma e. Negative 1, comma e. If I move that up 1 unit, which coordinate changes? Yeah, just the e, the y coordinate, right? So this is just going to go up 1 unit. It's going to be about right there, but let's label what it is. It's still negative 1, and if I take e and add 1, it's about 3.7, but we're going to write, so this is kind of the nice part, we're just going to write e plus 1. It used to be e, we added 1 to it, now it's e plus 1. Okay. This other one right here on that other graph was 1 over e. So if I take that point and I move it up here, that's where it needs to end up. It's still going to have an x coordinate of 1. What's the new y coordinate? Very good, I heard it back there. 1 over e plus 1. So the ugly part is, those aren't really nice expressions, but the easy part is, you don't really have to do the addition. All you do is say, hey, I know it's 1 over e plus 1. I'm just going to write that. Okay? Now, in reality, it would be like 1.37 or something like that. Okay? Any questions? Yeah. E is the natural number. It's called the natural number because it comes up a lot in nature. It has a lot of really unique features. So it's kind of like pi. Pi comes up a lot in math. E comes up a lot in math. Okay? All right. Anything else there? We're good? Okay. Another transformation on the exponential base e. What's wrong with the way this is written, Alex? The 2's in front. We normally don't write it that way. So let's just rearrange this. Let's write this as negative e to the x plus 2. What's the negative of vertical flip? What's the plus 2? Up 2. Okay? So we're going to take this graph that normally does this, exponential growth, like that, and we're going to do a vertical flip. We already graphed this once, so it's going to look like this. You want to think about what those points are and what the asymptote is. And we're going to take this and we're going to move it up 2. So what's the new horizontal asymptote? Okay, if it's right here at y equals 0 and I move it up 2, that's going to put me at y equals 2. Okay, so I'm going to find 2 here, and I'm going to go ahead and draw an asymptote there, and I'm going to label it y equals 2. There's my horizontal asymptote. Let's do the easy one first. Okay, I'm going to label these points just for the heck of it. -1, -1 over e, 0, -1, and this point right here would be 1, -e. Okay, those are all on the original graph. I'm going to take each one of those and I'm going to bump them up 2 units. Which coordinate changes again? The x or the y? The y does. All I need to do is take every one of those y coordinates and move them up 2. So I'm going to add 2 to the y coordinate. -1 plus 2, 1, 2, puts me at +1. I'm going to take this and bump it up 2 units. There's 1 and there's 2. It's going to end up right here. How would I label that point? It's still at 1, and now it's at -e plus 2. That's it. That's all you have to write. That's correctly labeled. Because if it was at -e and we bumped it up 2 units, we moved it up 2. So it's -e plus 2. That one would be 0, 1. And how would I label this guy right here? I'm just going to take this point that's here, and I'm going to go up 1, 2. So we're right about there. So nice big fat point there. How would I label that? There we go. -1, -1 over e plus 2. Okay. Can I erase all the black stuff? Okay. We were just using that shape so that we could tell where the points were and then we could move them. How many of you are planning on taking trig eventually? A couple of you? Okay. That technique is going to be really helpful. Get the right shape and then move the points. So it's going to run along the horizontal asymptote. It's going to hit that point, and that point. There's where the bend really happens. And there's our graph. Again, if you labeled this way, nobody's going to argue that you don't know what you're doing. Okay, are there any questions? Yeah. Okay, so on the original graph, this point was 1, e, and we did a vertical flip, so that would bring it down here. That would be 1, -e. That's part of the parent graph. You plug in a 1 here, you get out an e. It's e is about 2.7. So we'd go over, so this is, another way to label this point would be 1, 2.7. So we go over 1 and we go up 1, 2, that's 3, so we'd back off just a little bit, about right there. You can't label it perfectly or graph it perfectly, you can just come close. So it's about 2.7, so I'd take anywhere in between 2 and 3 if you were graphing it, okay? So if we took this and we moved it down 1 unit, for instance, this would have to come down here. We'd put it right there. It would have to be somewhere in, if this is in between 2 and 3, this would have to be between 1 and 2. Okay? Does that work? Okay. Anything else? Okay. Those are the transformations that you'll have to do. And then you've got a couple problems on the assignment where you're solving exponential equations. You did a few of these in Math 1010, so some of this is just going to be a quick review. The easiest way to solve an exponential equation is to write both sides using the same base. Okay? So I've got an example right here. These are not very tough, are they? The only way 2 to the x can equal 2 to the second is if x is equal to 2. It's that simple. If they're both written with the same base, you just say, look, if the bases are the same, then the exponents would have to be the same, and I just set that exponent equal to that exponent. This one is slightly more difficult. In order to solve these, we'd have to write both sides using the same base. So this is going to be 2 to the 3x minus 1. And I know I can write 8 with a base of 2. So again, this is all about practicing with exponentials. So this is 2 to the third. Now, once the bases are the same, the only way the two numbers can be equal is if this exponent equals that exponent. So I just take 3x minus 1, set it equal to 3, and then start solving like normal. So I'm going to add 1. So I'm going to get 3x equals 4. Then I'm going to divide by 3. So the answer to this problem is 4/3. If I take 4/3 and I plug it into that equation, it will give me an 8. It will make the equation true. Any questions there? Okay, let's just double check this really quickly. If I did 2 to the 3 times 4/3 minus 1, let's see what I get. First of all, what is 3 times 4/3? I can cancel the 3's, so I get 2 to the 4 minus 1. What's 4 minus 1? 3. Whoops. Was thinking 2 and wrote 3. What's 2 to the third? 8. So it is true. It does work. Okay, again, the key here is writing both sides using the same base. We write both sides using the same base. Can you write 32 with a base of 4? The answer to that is yes, you can, but you'd have to use fractions, and that's no fun. So what we'd want to do is we'd want to think about this, and on this one we only had to change this side. We had to write 8 with a base of 2. Could I write 4 with a base and 32 with a base that's the same base? Base 2, right? So here's what we do. 2 squared is 4 raised to the x, and 2 to the 5th is 32. 2 to the 5th is 32. 2 squared is 4 raised to the x. Power to a power, what do you do with those? Multiply them. So that's 2 to the 2x, and that's 2 to the 5th. Once the bases are the same, this means we can say 2x equals 5, which means x equals 5/2, and that's the answer. So again, the trick is write both sides using the same base. Sometimes you have to change just one of them. Sometimes you have to change both of them. So let's take a quick look at the rest of these examples. Do I have to change both or just one? Just one. This is going to be 3 to the x cubed. This is going to be 3 squared to the x. 3 to the x cubed. 3 to the 2x. Once I have it here, once they have the same base, what do? Set the exponents equal to each other. So that's going to be x cubed equals 2x. What do you do now? It's a cube. We can't really take a cube root. Here's your hint. Usually when we come across something like this, it's best to set it equal to 0 and then factor. What's the answer that comes from here? X equals 0. That's one answer. Okay? When does x squared minus 2 equal 0? When x squared equals 2, or if I take the square root, when it equals plus or minus 2. So how many answers to this problem are there? There are actually 3. 0, positive radical 2, and negative radical 2. All 3 of those. Any questions there? Okay, let's take a look at the next one. Can you write both sides using the same base? Okay, watch carefully. 5 squared to the x, that's not a problem. 5 to the negative 1, isn't that 1/5? So this is 5 to the 2x equals 5 to the negative 1, and then to finish solving, You just set the two of those equal to each other. So what is the answer to this problem? Negative 1/2. Okay? All right. Now, I'm not going to solve all of the rest of them, but we are going to set them up. So please take a look. Change them both or change one? Just one of them. 3 to the 2x minus 1. 3 to the, let's think about this. 81 is 9 times 9, and both of those 9 are 2 3s. So this would be 3 to the 4th. Okay? Set the exponents equal and solve. Any questions there? Okay, I'm going to skip over to this one right here. Going to look at H. Can I write 1/2 and 8 using the same base? Very good. 2 to the negative 1 to the x plus 1. 2 to the 3rd. Again, we're using those properties of exponents. Power to a power, what do I do with these? Multiply them. So this is 2 to the negative x minus 1 equals 2 to the 3rd. And once you have it here, set them equal and solve. Good? Okay, couple more. Kind of ugly. What base are we going to use? We're going to use a base of E. So there's nothing we can do with this one. Let's take a good look here. What's the first thing we'd want to change? We like that. I mean, that's base E. This would be e to the negative 3. Move it up in the numerator, changes the sign of the exponent. When we're multiplying these together, what do you do with the exponents? Add them together. Very good. So this is 3 to the x squared equals e to the 4x minus 3. And then all you have to do is x squared equals 4x minus 3. Again, keeping in mind what we did just above here, how would you normally solve something like this? Set it equal to 0. X squared minus 4x plus 3 equals 0. Can you factor that? You bet you can. Okay, that does factor. So I'm going to write factor and solve. Knowing what we know about solving polynomials, how many answers will you get? You'll get 2. Okay, you'll get 2. What if it didn't factor? Very good, Chase. Quadratic formula. Okay, last one. Take a look at this. So I've got 5 to the x, 25 to the negative x, and 125. What base am I going to use? We're going to use 5. So we're going to write each one of those using the same base. So we're going to use a 5. So I like 5 to the x. This is 5 squared to the negative x. And what about 125? 5 to the 3rd. So this is 5 to the x. This is 5 to the negative 2x. 5 to the 3rd. Okay, and as awful as this one looks, what do you do with the exponents? Okay, you have to add them first. Okay, when we're multiplying exponentials with the same base, we add the exponents. So what is x plus negative 2? Or sorry, x plus negative 2x? Negative x. Can you look at that and tell what the answer is? Negative x equals 3, so x has got to equal negative 3. There we go. That's it. Okay? All right. I'm going to give you some time to work on this on Monday. Please get started on it, but bring your book to class on Monday. Have a great weekend.